Okay, you guys, sine of theta is 1 over 2. Cosine of theta is negative square root of 3 over 2. What quadrant am I in, Connor?
2.
He says 2. No? Yeah? You guys agree it's 2?
Yes.
Okay, this is sine of theta. Sine of theta is positive. Where's sine positive? 1 for sure and
2.
Okay, so you're either here or here. But wait a minute, cosine is negative. Cosine is negative where? 3 and 4.
2 and 3.
Yeah, 2 and 3. So this is where you'll find sine positive, cosine negative. It's here. There, there, there's your triangle. And this is really the angle we're looking at, right? But the reference angle is right there. Sine of x or theta is 1 over 2, opposite over hypotenuse. This one's cosine of theta, adjacent over hypotenuse. There it is. Secant, cosecant, tangent, all that. What is secant? Morgan, what is it?
Negative 2 square root of 3.
Say it again. Negative what?
Negative 2 square root of 3
Over 3. It would be R2 over this. So you're going to get, yes, you've got it. That's right. Okay, next cosecant is what, Will? Oh. Give me which one? 2 over 1, okay. Okay. Cosecant is a reciprocal of sine, so that should be pretty easy without even looking at the triangle. Tangent is what? Kyle?
Negative square root of 3 over 3.
Negative square root of 3 over 3. Yeah, because it's really 1 over negative square root of 3, and then you rationalize. There you go. So 1, 2, 3. Last one, cotangent. Maddie, what do you think? Oh, Maddie, I forget there's 2 Maddies. Sorry. I'm looking right at you. Maddie Belgard. Negative square root of 3 over 1, yes. And there you go. Okay, so there's a review, quick review of what you've been doing. All of this, though, I want to tell you, we could have used any of these identities to solve that, but that is something you've done. So it's just a quick reminder of all the things back in chapter 4. Okay, so where are we going now? We're going to go to chapter 5, and chapter 5 is going to talk a lot about analytic trig. It's a branch of trigonometry that deals with the properties and relations of trig functions, which we covered. Okay, using fundamental identities. Okay, these are the goals for chapter 5. Okay, today you're going to do this. You're going to evaluate trig functions. Okay, you're going to use your identities to evaluate them. Simplify, and there's the word simplify. Simplify trig expressions. So this is pretty much today. Okay, tomorrow and I'd say Friday, Monday next week. Okay, there'll be additional trig identities coming up later in the chapter, and then solve trig equations. That's still a week and a half away. All right. Purpose of this lesson: to familiarize yourself with and practice using fundamental trig identities. Okay. Now, I have to tell you something about identities. It takes a lot of thinking power to get from here to here to here to here to here to the answer. Sometimes you're going to say, oh, that's easy. And then sometimes you're going to go, oh, I don't know where to start. So you just have to get better by practicing. It's all you can do. Okay, so here comes our first problem. You're going to open your book tonight and go, oh, look, they want me to take cosine times tangent. Cosine times tangent. Okay? Well, you know, when I see cosine and I see tangent, it's like saying x times y. Can't do anything x times y. It's xy. So that is not the answer. We got to simplify this. Get it down to something smaller. So one of these two you're going to have to do something with. And if you look at your trig, well, you got to look at your paper because I don't have the reciprocals up here. But look at it. Do you see anything I could do, replace something with something?
Replace tangent with sine over cosine.
Okay. All right, Molly. Molly says do this. Change tangent to sine over cosine.
The cosines cancel.
Because when you multiply, you just go top, top, bottom, bottom, but cancel first, right? Cosine of x would be the same exact answer. They cancel out. Final answer? Sine of x. There you go. So now it becomes, how can I replace what I see with something else so that I can cancel things out? That's multiplication, knocking out cosines. Sometimes you have addition, subtraction, and they knock each other out. It's nice. Okay, you guys can see this, I think, right? So let's try these. Okay. All right. See what you can do on that one. Maybe you can get it. Maybe you can't. I don't know. I look at this and I go, 1 minus cosine is cosine squared, that is. It's like this. Times cosecant. Well, cosecant's a different function, so I can just say that's y. I mean, what would you do to that problem? Just simple.
Distribute the y.
Yeah, you distribute the y. This is back in 9th grade. You did that. Well, it's the same thing here. But before you do that, look hard at this. Do you see anything that maybe could be replaced? Okay, Grace says 1 minus cosine squared is really just what? Sine squared. Okay. Okay. Okay, there it is. All right, how'd that help?
Not yet.
Yeah, go ahead, Morgan.
Change the cosecant to 1 over sine.
Okay. Change the cosecant to its reciprocal. Its reciprocal is 1 over sine, right? Okay. Then multiply it by what? Sine squared. Well, sine squared, just, I know you don't have to do this, but, whoops, I didn't mean to do that. Sorry. I meant to do this. Just rewrite it like that. So looking at that, guys, that's just sine times sine over 1. Well, what's going to happen?
One of the sides.
Yeah, one of the signs is going to cancel with the other one. Okay, so let's say these two go away. What's the answer?
Sine.
Sine of x. Got sine of x twice. That doesn't happen very often. Okay? Look, look, look. Try this one. Look at your identity sheet. Look at it. There's something you can do. Noah, anything? Anything I can do up there?
You can make cosine of negative x into cosine of positive x.
Okay, yeah, it's an even function, and look at your identities. It does say right there, and I tried to show you why this works, but cosine of negative x is really just the same as
Cosine.
cosine of positive x times sine squared. Good? What now?
They cancel.
Cosines cancel, don't they? Everybody agree?
Yes.
Everybody agree?
No.
Hunter, do you agree? Why not, Hunter? Why not?
Because you're multiplying it by a different number, and multiplying comes first.
Yeah, I mean, this is cosine. You're looking at minus cosine, but these are hooked together, aren't they?
Mm-hmm.
Yeah. See, they're not opposite terms. And first of all, think about this, guys. If you went like this, This is cosine of x. That could be like x minus cosine of x is another x. That's sine squared. That could be like y squared. What would you do in algebra 1 if you had that? Are these like terms? Do they cancel out because it says x minus x? Not even close. These are not like terms, and those are not like terms. You can't cancel out. So everybody got it wrong. When I say cancel them out, don't do it. Okay, what do we do?
Do we factor out a cosine of x?
Okay, he wants me to factor out the GCF, cosine. Let's try it. Okay. Times
1.
1 minus,
1 times sine.
well, I don't have to put 1, do I?
Yeah.
Yeah, just go sine
Squared.
root of x. Okay, good. Now what? Look. Hey, anytime you see sine squared in a 1, or cosine squared in a 1, or tangent squared in a 1, yeah, it's your Pythagorean identities. It's this one, isn't it? Right here? 1 minus cosine squared is?
That one.
Cosine.
Oh, I said that wrong. 1 minus sine squared is? It's cosine squared, exactly. Okay. Final answer?
Cosine cube.
Yeah, it's cosine to the first times cosine to the second. That's cosine to the what?
Third.
Cube. Guess what? Period 4 didn't do it that way. Period 4 took a different direction, and they got it. So here's the bad part about identities. There's no one right way to do it. You can go that direction and still get there. You can go that direction and still get there. It works.
Which way was easier?
Which way did you think?
I think this one's easier.
I think you guys picked the easier. I did too.
Okay.
When you guys picked this way, I went, this is better. I don't remember what they did. I just know they did it different.
Oh, they turned sine squared into 1 minus cosine squared.
Gotcha. Yes, they did. They went like this. They crossed this out and they just said 1 minus cosine squared. And then we distributed the negative cosine through, and then everything just canceled out, and it turned out to be that. That's what they did. But here's the deal. You're going to work your assignment. And Will, you might do it one way, but Tanner, you might do it another way, and you both get it. You know, it just depends on which way you think of it. Okay, here are 3 problems. Every one of them, they just want you to do what? Factor. Okay, algebraic techniques, it says on top. So they're trying to bring it back to something you already know how to do. So you have to think back to algebra 1, when this looked like something from algebra 1. Rewrite each expression as a product of 2 factors. This times this is 1 minus cosine squared. Does this have a look that you know, that you remember? Difference in what? Perfect squares. Yeah. Doesn't this have the same look back in algebra 1 when you did this? Perfect square minus perfect square. X squared minus y is the same as?
X plus y, x minus y.
X plus y, x minus y, exactly. It's the same look. That's a perfect square minus a perfect square. What's the answer? 1 plus cosine times 1 minus cosine should do it. Sorry. Plus cosine, 1 minus cosine. Okay. There it is. Just so you know, x is theta. And that's why I switched it over. I tend to do that a lot. Okay. Look at the next problem. Does this have a look that you remember? That was 2 terms. That's a binomial. And of course, Hunter said that looks like the difference of 2 perfect squares.
That one's a trinomial.
That's a trinomial. It has the look of something like this. Maybe an x squared plus 5x plus maybe a 6 or something like that. Doesn't this kind of look like this? And of course, this would be x what? X2 plus x plus 2x minus 2, yep. 3 plus plus 3. There you go. Okay, this has the same look. It's a trinomial factored into 2 binomials. See what you get? Paul, what did you do to get that first term times first term to give you this?
I just finished writing.
You just,
I just finished writing down the question. I didn't even start yet.
okay, that's okay. Carly, what'd you do? No?
3 times cosecant and the first one, the second one is just cosecant.
Okay, so you're saying a cosecant times a cosecant gets you a cosecant squared, right? Okay. Yeah, and then he says make sure you put a 2 in front of one of them because 2 times 1 is 2. Would you agree? 2 cosecant times 1 cosecant is 2 cosecant squared. Okay. Yeah, and then of course, here's the deal. Last hour I got a little confused. I forgot. I did a 1 here, and a 1, when you have a 1 there, it's so easy. When you have a 2 or 3 or 4 here, it gets a little more complicated. You gotta be careful. I need 2 numbers here and here that will give me 6. But when you do the inner, outer, it's gonna add up to -7. They're both what? They're both negative, yes, because negative is positive.
Negative 3 and negative
3 and 2. Okay, this is what Gray says, 3 and 2. Is it right? Let's see. This times this, inner is negative 3 cosecant. Outer is negative 4 cosecant, which makes -7 cosecant. So, Grace, good job. She got it. Good. You know what? That one was nice. Cosecant squared in front, cosecant in the middle, and constant in the end. You know why this one's not so nice? You got a secant and a tangent, and it just messes the whole thing up. It's like having an x squared in front and a y in the middle. That doesn't work. So now you got to use your identities. Change it a little bit to get them to both be secant or both be tangent. Tanner, you got any idea? No? Kyle? You can look at your identities, but if you look at your identities, this identity of this is cotangent, identity of this is cosine. Ah, that doesn't help.
Couldn't you do that one? Make it tangent squared.
Okay, so your secant squared is right here. Well, there it is right there, guys. We can change secant into tangent if we just replace this with this. Do it. Go. And get the answer. Change secant squared to tangent squared plus 1. See what happens.
Did you?
Okay, so secant squared turns into tangent squared plus 1. Plus 3 tangent of x plus 1. Well, the ones in the back and the one in the middle turned into what? 2. So tangent squared of x plus 3 tangent of x plus a 2 right there. And this is a nice one because the coefficient in front of your squared term is what?
1.
Yeah, this is a nice one. At least I hope it is. Okay.
Oh, it is.
It is. Boom. Taylor, what's the answer? Tangent, tangent, gotcha. Okay. Yep. Two numbers that multiply give you 2, but add up to 3. It's gotta be what? Plus 2 plus 1. If you FOIL, this would be 2 right there. If you inner, it'd be 2 tangent with a 1 tangent, which makes 3 tangent. It works. Yeah? Factoring. Factoring can make your problems easier because you might be able to cancel things out, or maybe add, subtract, and they just disappear. It's nice. It's a nice tool. That's all factoring ever is. It's a tool to get you the answer. Okay, now we got to do something like this. Add a couple fractions together. Combine the fraction over a single denominator, then simplify. So, this is a fraction, 1 over cosine squared, minus 1 over 1. Okay, there it is. Common denominator. What? Okay, you're not saying anything. Ready? 1 over cosine squared is like 1 over 5 plus 1 over 1. What's the common denominator? 5. 5 times 1 is 5. What's the common denominator? Cosine squared. This times 1 is cosine squared. Okay, so it's really just cosine squared. Oops, that's a minus. Cosine squared.
It doesn't look like a minus.
No, it isn't. Not yet, but it will be. Okay. Now, what do I do to this numerator right here? Nothing.
Nothing.
What do I do to the next one?
Make it cosine squared.
Yeah, you have to multiply the bottom by cosine of theta, multiply the top by cosine of theta, and you get cosine of theta. Right?
Didn't you get cosine squared of theta?
Yeah.
Oh, I'm supposed to multiply by cosine squared. Cosine squared, which is cosine squared. Okay. Now you're asked to add or subtract, so we have to perform what it says. It says to subtract them. When you subtract, the bottom's not going to change, right? Common denominator, right there. Numerator is going to be what? 1 minus cosine squared.
Sine squared over cosine squared.
Right. This is this. Go back here. It's really just what? Sine squared, right? Sine squared over cosine squared. Okay, don't quit yet because you should see it. When you see sine over cosine, yeah, it's tangent, isn't it? But because they're both squared, it's going to be tangent squared. Okay? Good? Can you see the next one or not?
Nope.
All right, try the next one. Okay. Before you start, look up. If you had 1/5 plus 1/7, what's the common denominator?
35.
So what'd you do to the 5 and the 7?
Multiply them.
There's your hand. That's your hand. Get your common denominator first. Everybody agree? If you multiply the two denominators, they will both go into it? Just like 5 times 7 is 35, 5 goes in 35, 7 goes in 35. Okay, so this is it. 1 plus sign, 1 minus sign is the common denominator. Okay, go back to the beginning and say, ask yourself, what do I need to multiply the first fraction? What would I multiply this by to get it to look like this? 1 minus sine. So up here you go what? 1 minus sine. This would get you 1 minus sine. There's not much to do here. Run the one. This one you'd multiply by what? 1.
Plus sine.
Yeah, I think you want to go 1 plus sine. To get it to, the bottom has to look like the bottom here. And then 1 plus sine is what? 1 times this, 1 times this. 1 plus sine. Okay? Common denominator is there for you, so you don't have to do anything. Don't change your common denominator. 1 plus sine, 1 minus sine. But on the top, did anything happen?
It's 2.
Just 2? Because what do the signs do?
Cancel.
Yeah, they're like terms and they're opposite. 1 sine theta minus 1 sine theta. They're out. You get what? 2. Okay? That's not a very clean look, by the way. So what could I do from here?
And then the cosine squared after
1 minus sine squared. Wait.
Yeah, you
Yeah.
add 1 minus sine squared, and then that turns into.
Okay, so you're foiling. That's what's hoping you say. Foil it out on the bottom. If you foil it out on the bottom, inner, outer, cancel. 1 times 1 is 1. Okay, the inner and the outer, when you multiply, cancel out because you get minus sign plus sign cancels out. And a sine times a sine is
Sine squared?
negative sine squared. Okay. That looks a little better, but we can keep going. 1 minus sine squared is cosine squared, isn't it? Keep going. 2 over cosine squared. Looks good. Except you really don't want to leave your answer. I know I have one trig function, but don't leave it as a fraction. Think of your reciprocal functions. Secant squared over 2. I knew you were going to do that. Okay, I got to show you something. Watch this. You got to think of this problem as, how would you get that answer? It's 2 over 1 times 1 over what? Cosine squared. This is really this, correct? Okay, so now this ends up being 2, and then this is what? Secant squared, yep. And that's as simple as I can make it. You went from that big mess up top all the way down to here. Now you get there, guys, and that gets a little confusing. So if you break that up in your head or on paper it looks like this. And the 2 is just the 2. 1 over cosine squared is secant squared. Good? Okay. Just so you know, I'm hammering you today because I need to get this through. We got a short period tomorrow, guys. So I want you to work tomorrow, okay? And I'm not going to make it. I thought I could get this one in, but I can't. So this will be tomorrow. Now, at the end of your assignment today, you're going to see this kind of problem where they say, eliminate the denominator. If you want to read about it, this is really a simple problem, but I'm not going to have time to talk about it. So if you want to read about it, you can do it. If you want to skip it tomorrow or tonight when you're doing it, skip it, and we'll do it tomorrow. Tomorrow is mostly a work day. Problem is we got a pep rally. So,
What are 8 hours?
no, you guys got to cut.
Now you can see.
You're 45. Everything's 45 tomorrow except for period 6 and 7. They go really short.
I got 114 Mr. Lemon's video.
Really?
You know more than the teacher.
Yeah.
14% more than the teacher.
I was the anchor of Central News. So, yeah. Actually did a quick story on the GSC hockey. Will had the mic. Cut that clip out.
Hey, do your best on this. Don't do. It's a 2-day lesson, but get some of it done.
Why did
If you
come
run into a
home
bad
today?
one,
We didn't
skip
get
it,
the
go to the
doctor
next one.
to
Might be easy for you.
Oh
Some are
yeah.
gonna be easy, some are gonna be medium, some are going to be hard for you. Okay.
Should I bring it up?
Yeah.
Mr. Painter said that I couldn't. You said I couldn't come home unless we beat Valley City.
I know.
And
you
what
were
did we
scared,
do?
weren't you? You were scared. What did they do? They beat
Wish
us by
I
one. Thought I had your number. I had to text you though.
We'll
Paul, did you just push somebody down? Or what?
give them your phone.
You're not gonna score. So how did it end? I gotta know. Like, did you make it? Those buckets?
No, we were up by 4, and they just hit a 3 halfway.
You knew you had it in the bag. Just don't fall. Is anybody close? Trying to put his hand up or something.
No,
Back up.
we're all told to just leave
Then they just foul the ball because he's the worst free throw shooter. Go ball.
So Eddie, what did you do on that test?
67, like I said.
Okay,
You got it. Sam.
hang on one
Yeah,
second.
except he edited it because like.
Oh, no.
Did you?
Oh, we haven't done this. Cancel that.
That was 7.
Hit this right here. The black